Hello, I'm Teanna Barrett, and today I'll be presenting Skin Deep, investigating subjectivity in skin tone annotation for computer vision benchmark datasets. So the origin of skin tone annotations in computer vision actually lie in the computer vision failures that have compounded systemic racism and anti-Blackness in the United States. And with all of these examples, the computer vision community has an obligation to resolve these disparate performances. However, unlike other domains of machine learning, computer vision is skin deep. Therefore, race data is not race data and annotations are not the best way to understand performance gaps within computer vision data, which are images of humans. And as the hallmark paper Gender Shades shows, skin type is a potentially more objective way to categorize computer vision datasets through annotation. While this skin tone annotation process has promise, there are a lot of social issues associated with skin tone annotations. One, for instance, is the measurements for skin tone annotations. The Fitzpatrick scale and the ITA scale are popular scales that are used that actually derive from the realm of dermatology. However, when computer vision practitioners adopted this, they did not clearly contextualize how these scales were first actually only made for Caucasians, and it took the work and callouts of dermatology researchers for the scales to be expanded to what they are today. And even now, these scales are still lacking in the representation of darker skin tones and the representation of skin tones of people of Asian descent. However, the monk scale that was recently proposed by Google offers a larger range of skin tones in order to close this representation gap. However, it has not been publicly evaluated as to date. In addition to skin tone annotation measurements, skin tone itself is embedded with also a lot of social context, similar to race. As the namesake of the Monk scale, sociologist Dr. Monk explains, there's a legacy of skin tone discrimination that still informs perceived and material social statuses within the United States. And these statuses can be implicitly and explicitly embedded in the perspectives of potential annotators and the designers of these skin tone annotation procedures and processes. Given this, our research focused on how, one, do computer vision researchers conduct and report on skin tone annotations, and this was explored through a literature review, and two, what social factors impact the uncertainty of skin tone annotations by human annotators, and this was done through an annotation study. Firstly, for the literature review, we collected 50 papers from these variety of publications and computer vision venues and encoded them to understand how annotation procedures are conducted and what uncertainty analyses they provide about their annotations. Unfortunately, out of the 50 papers we coded, only 9 of them described skin tone annotation processes, reported skin tone annotation uncertainty, and provided distribution of these skin tone annotations. And the vast majority only met at least one requirement of the robust skin tone annotation procedures. And many lacked transparency about the whole process, which an example of the quote below was the full extent of their explanation of the skin tone annotation process. And the majority had no uncertainty analysis. A third orthogonal category that arose that we found very interesting is how papers embedded race in their skin tone annotation procedure. Whether it was collecting race metadata in addition to skin tone annotations or using associations between ethnicities and nationalities to select images for the data set, as well as just clear jumps to harmful racialized language in place of more objective skin tone annotations was a large-scale issue that was not perceived beforehand, considering how skin tone was supposed to be a separate annotation and more objective annotation than race. Given the unstandardized nature of current skin tone annotation procedures, we conducted an annotation study that looked into what factors that were mentioned in these previous annotation procedures could potentially impact uncertainty and agreement, such as scale type, scale ordering, image type, and annotator skin tone in terms of their positionality and implicit bias. Our annotation system that we built was a continuous annotation scale in which the annotator placed a lower bound value and an upper bound value to represent the full skin tone annotation of a single image, as the one pictured in the middle. Then we also collected the annotator's skin tone before they completed the main task, as well as collected information about how they considered race throughout their annotation process. Once our pool of 165 participants were collected, we then derived these findings. Firstly, as a sanity check, we looked through and compared how closely correlated the popular Fitzpatrick scale is to the newer and more expansive Monk scale, and found that these scales are actually highly correlated with each other and have little impact on the annotations made. Secondly, we want to understand how the scale type, the ordering of the scale, or the image type affected the agreement between annotators. And we actually found that there was higher inter-rater agreement with the face dataset. In other words, the dataset that had images that were primarily used for facial recognition tasks and computer vision. Then we also looked at the scale type, the ordering scale, or the image type to understand the uncertainty within an individual annotator. And we found there is actual lower individual uncertainty when the scale was ordered from darker to lighter shades. Finally, when understanding how the annotator's self-reported skin tone, which can be understood as their positionality or implicit bias, affected their uncertainty or agreement, we broke it up into two ideas. First, value bias. We found a slight value bias towards the annotator's own skin tone when assigning skin tone values to the various images. On the other hand, in terms of uncertainty bias, there was a slightly more certainty for images that are actually different from the annotator's skin tone or farther away from what the annotator actually annotated themselves as. So given the understandings that we gained from the literature review and our annotation study, we sufficiently demonstrated how subjective skin tone annotations actually are. And with this, we encourage and strongly encourage any computer vision practitioner interested in understanding the need for skin tone annotations to first consider the association between race and skin tone and how skin tone and race actually do not equate to each other when building their studies and providing this context to their annotators. Secondly, we also see an interesting avenue for how the design of the skin tone annotation process can challenge skin tone stratification. Finally, there's an obvious lack but need for transparency in skin tone annotations, because without this transparency, it'll be hard to understand and anticipate what downstream effects the subjectivity of skin tone annotations can have in performance evaluations, audits, and eventual improvements to the various computer vision tasks that need to work better for people with darker skin tones. Finally, we'd like to thank all of these groups for helping us and providing support in a various amount of ways to this project. And finally, thank you. And if you would like to contact for any information, please do. And also check out the paper. Thank you.